B. Dhanasegar is working as a lecturer in Department of Information Technology, Anna University, Chennai. He finished his MCA from Urumu Dhanalakshmi College, Bharatidasan University. He finished his ME in Computer Science and Engineering from College of Engineering, Anna University. His areas of interest are multi-core programming and architecture, programming models, compiler, automata theory, cryptography, and algorithms. He is an expert in subjects like compiler design, formal languages and automata theory, analysis of algorithms. His research area is code generation for multi-core architecture.
Welcome to the UGC lecture series on computer science. Here we have the subject called compiler design. So this is a first part of the subject. There is various lectures that is in compiler design. So this is a very important subject as far as the field of computer science is concerned, and you can find out this course as part of almost all courses or all degrees related with computer science is concerned. So what we learn about this in this subject is, so given a program, how it is translated into its equivalent object version, that is object code. So every program is supposed to be executed on your computer, and if you are executing the program in the computer, the language in which the program is written should be known for the computer. So what a computer or a machine can understand is only a machine language, but in the initial days people were doing programs on machine language itself, but after considering the difficulties in writing code in machine language, people thought of coming for some kind of various versions which will be easier for programmer, but at the same time we have to understand that they are difficult for the machine. So when we find something is difficult for the machine, we need to translate it into the native form which is known for the machine. So once we make the transformation, then programming will become easier as far as the programmer side is concerned, and at the same time it will be easier on the machine side is concerned once the translation has been done. So now the question is, how the translators are written, what are the types of translators available, and how these translators are transforming the programs into the object version. So what kind of inputs they are accepting and what kind of outputs are all possible. These are the questions we need to find out the answer. As far as this subject is concerned, we will be talking about the compilers, which is a translator translating your high level language program into the low level language program. Let me start with the definition for translator. So they are programs accepting one form of language as input and producing another form of language as output. So translators itself is a program, but once again the question now arises, if you are writing a translator in a programming language, who will be translating that program into its equivalent object version? So we have a topic called bootstrapping of compilers. So how the first compiler was emerged. That is, if you are writing a translator in high level language program, which translator has translated that high level language program into its equivalent object version, so that your compiler is now becoming an understandable one for the machine. So if the compiler can't be understood by the compiler, that is machine, then there is no point in translating your code. Your translator should be in machine form, but if the translator is written in high level language form, who will be translating that? So we have the concept of bootstrapping of compilers, where the compiler or the high level language program comes in various stages, starting from the machine language to then assembly, then high level language, then finally we will be having a complete version of the high level language program, for which the translation is self, it is not needed. So then once the translator has been available, then you can, that is when you are designing the translator itself, we will specify what is going to be the input for the translator and what is going to be the output for the translator. So based on the input and output for the translators, we will define or we will classify the translators into various categories. So some of them are available here. One is going to be the compiler, another one is interpreter, then we have assembler, then we have macroprocessor, we have preprocessor, we have silicon compilers, so etc. etc. So, there are plenty of there is types of translators available, but the most familiar one is going to be the compilers. That is the reason why we have taken this subject compiler design as far as this kind of lecture series is concerned. Let me start with the definition of a compiler. So, it is a system program. Once again, it is a system program that translates high level language program. So, if you are looking at the definition of a translator, it translates one version of a program into its equivalent another version of the program. The reason why we call it as equivalent means whether the program is in form 1 or in form 2 or whatever it is, the ultimate semantic of the programming language or program must be same. That is, what is the task being achieved by the program, irrespective of what version it is or what language it is, it must be same. So, that is what we call it as equivalent program. So, a compiler now reads a language which is called as high level language program, and it reads high level language program and transform it into the object code. But when you are looking at the object code, so it can be a machine language or it can be an assembly language. Nowadays, we can even have a compiler translating one high level language into its equivalent another high level language program also. So, those type of compilers are also possible. So, provided the target for the compiler, the target language of the compiler could be translatable at some stage definitely into assembly language and then into machine language. Unless otherwise we transform the high level language program into its equivalent machine language form, maybe in direct step, single step or in multiple steps, the program is of no use. So, every program irrespective of the compiler used must be transformed into some object language, or object language I mean the machine language, so that the program will be executable and we can really find out the benefit of the code. And here the compilers. So, we have the source program which must be a high level language, and the object program it can be a machine language or even an assembly language. And some examples like the COBOL compiler, Fortran, C, C++. So, there are plenty of compilers written for every language. There will be a translator needed, but many of the languages are coming up with compilers as their translators. So, now look at the another translator which we call it as interpreter. So, this is once again a translator, it is a program and it is transforming the programming language. Once again the input of the your interpreter is same as the input for your compiler, but what kind of language its target is going to be some intermediate language which can be directly executed. So, we will come up with some intermediate language which could be understandable for the machine. So, there is a huge difference in between the translation being done by compiler and the translation being done by interpreter. So, that is available after a few slides, but time being let's just understand the definition of a interpreter. It accepts a high level language program as input and producing intermediate language which can be directly executed. The meaning of directly executed means there is no further need for translating that intermediate language into a form which can be understood by the compiler, the computer. So, that is the reason why we say that it is directly understandable to the machine. You read a line, translate it into the machine language or the intermediate representation such that the intermediate representation can be understandable for the machine. So, one example language is Snowball, string name object oriented symbolic language, which has an interpreter, and the code being produced is going to be the Polish notation. So, this is a postfix notation. So, this is going to be an intermediate language which can be, that is very easily and that is executable without the knowledge of another translator. So, that is what the important point here, whether the intermediate languages can be directly executed or not. So, the intermediate language, if it is directly executable and if the intermediate language is the target language of the interpreter, then this is going to be a proper way of translating your program from high level language program to the intermediate language. The next translator we are having is the assembler. So, that is another way of translating your program, but here the input language is slightly differing. The input language is not the machine language, sorry, not the high level language, but the input language is an assembly language program. So, the assembly language program has the power of that is intermediate power in between your high level language program and a machine language program. So, the assembly language is available in the form of mnemonics, add a comma b or subtract or go-to. So, these kind of simpler object codes are there as far as assembly language is concerned, and these kind of programs are easier than writing programs in machine language, but not as much easier as writing program in high level language programs. So, but once you are having an assembly language program, so it could be compiled or it can be translated by using an assembler which produces the machine language equivalent for the assembly language program. So, now suppose if you are having a high level language program, so what is the necessity for an assembler? So, most of the compilers what they will do is producing the assembly language as the target language, and the corresponding assembler will be invoked for translating the outcome of the compiler. The outcome of the compiler, I mean the assembly language, into its equivalent target language. So, into target language means that it is going to be the object language. So, the reason why we go for separating the compiler from an assembler is, when you are finding the target language is an assembly language, the efficiency of the compiler is very well, or the complexity involved in designing a compiler is less. So, the compiler design becomes easier because most of the machine independent features are now available in the hand of compiler, and machine dependent features are available in the hand of your assembler. So, the task of your compiler is reduced or get reduced. So, we can have a compiler with very small size in code in terms of its execution. That is the reason why we will produce an assembly language as the target language of that is compiler, and we will be able to translate the assembly language program into its equivalent machine language, which is mandatory. Otherwise, even you can say that the assembly language is not going to be a language understandable for the machine. So, every assembly language program must be transformed into its equivalent machine language program, but the translator being used for translating the assembly language program into the machine language program is the assembler. And another one is we have the macro processor. So, a macro processor is a system program. Once again, it is a program which replaces the macro calls in any assembly language program by the macro definition. So, here the meaning is, so we all know that a programming can be done in modules, or you can even go for straight line codes, but when you go for module based programming, we will be writing functions for doing certain jobs, and which when invoked, it will do the job as expected by the that is function. But when you go for assembly language programming, we do not have the straightforward concept of functions due to the complexities involved in handling them, but we have a concept called macros. So, their objective is going to be very similar to the objective of a function, which has a name. There will be some list of formal arguments and followed by some body of the there is macro. There will be some number of lines of code available, and because of the identity or the name available for the macro in the beginning, we will be able to there is execute those lines of code just by saying what is the name of the macro rather than repeating the code. So, when you go for macros, the code repetition can be eliminated, that is the code size can be completely eliminated. You simply write once and call as many times as we want. So, the concept of functions in high level language program is similar to the concept of your macros in your machine language assembly language programming. So, what we should do here is read a function, but when it is going for execution, so what happens is every call for that macro will be replaced by the corresponding function or corresponding definition. When you are writing program in assembly language, we will write a macro and that will be called as many times as we wanted to have. So, we will be able to reduce the size, or we will be able to control the explosion of the size of the code being produced as an assembly language program. But at the same time, once the program has been subjected as input for a macro processor, the macro processor will read or it will find out what are all the various macros available, macro calls available in your code, and every macro call will be replaced by its corresponding definition by replacing or by substituting the actual arguments in the place of formal arguments. So, for example, if there is a macro called add with two formal arguments a and b, and there is a line of some lines of codes are available, and there is a call for that add 10 and 7. So, in that case we will be having, that is the code which is wherever we are having a will be replaced by 10 and wherever we are having b will be replaced by 7. So, that is the purpose of your macro calls. So, macro calls, once we see, it will be replaced by the macro definition, which is job done by your macro process. So, I will continue this lecture after a short break. Welcome back. We are seeing what is a macro processor. It is once again a translator which is translating the assembly language program, where we have macro calls, into assembly language program once again, where we have no macro calls. So, when you compare it with the other translators like a compiler or interpreter, the source language and object languages are completely different. But in this case, your source language and object language are going to be same. So, a macro processor is never producing object code. A macro processor will produce assembly language code only as output, given an assembly language program as input, but the input language, that is input assembly language given for you, will be having macros with along with their definition, but the output program is having macro definitions only, but there is no call, because all the calls available in the macros are replaced by the corresponding definition after replacing the formal arguments by the actual arguments. So, that is the definition of your macro processor, and now there is a need for differentiating the compilers and interpreters. The reason why we are differentiating compiler and interpreters, when you look at the input output specification of both compiler and interpreter, they are almost same. The input for your compiler is going to be the high level language program. The output for the compiler is either assembly language or machine language. The input for interpreter is a high level language program. The output for the interpreter is an intermediate language which could be directly executable. So, that is what we call it as the object program. Anything which can be directly executed can be called as object program. But in what way they are different? So, in what sense or what conditions we can go for compiler, and where we will go for interpreter, which will be advantageous for us. So, what are the pros and cons? So, those things we must know, so that we will be able to decide on whether we have to go ahead with the compiler or with an interpreter for a language. So, the first point is, as far as the compilers are concerned, they will be producing the executable code in the specific media, but whereas interpreters are not producing the object code, that is your intermediate code on your specific media, but directly for execution. So, what we understand from this is, when a compiler is capable of producing object code directly in a specific device, it could be reused. So, I am compiling a C program, it will be producing an object version, that is some file name .exe, that is executable file. So, once that executable file has been generated, after debugging all the errors and all, we will be having exe file, but once the exe file is there in your hand, we can completely ignore the source program. Unless otherwise we need to modify the code, we need not bother about the source program at all. So, if you are designing a product and you are selling it for somebody else, then it is enough to give only the object version of your code, so that those guys, people who are going to be the users of that program, will not be able to modify the program and do changes on the program. But whereas when you go for an interpreter, it is directly producing the object code on memory, which can be directly executable. So, you can't reuse the object code produced by your, that is your interpreters. So, that is the reason why every time when we compile, when you are translating a program, a high level language program using a interpreter, it is required to have the source language or the source program. So, without the help of the source program, you cannot have the, you can't see the output of the program, even though we are translating it every time. So, we need to translate every time, and we must execute the code, and you can see the code, see the execution of the code, but always we need the source program. So, if you are selling this particular source program into somebody else who is also depending upon interpreter for its translation, you have to sell only the source code, not the object code, because object code cannot be reused as far as interpreters are concerned. So, we must give only the source program, and once you are giving source program, very easily anybody can modify the source program, so that they can that is even own the copyright, or you can by modifying them they can do as they like. So, that is the first point to be considered as far as the compiler versus interpreter comparison is concerned. Next one is, a compiled program is actually requiring very less time for execution, but interpretation requires more amount of time. It is because of a compiler is going to, the compilation is going to be a one time job. Means once the object code has been generated, then we can completely forget about the compilation process, that is the translation process, and we can use the executable version for execution. But whereas in the case of interpreter, every time if you want to see the output of a program, every time we must translate from the source program to the object version, and the object version gets executed. So, always your interpretation is a time consuming process when you compare it with execution of a code which was produced by your compiler. So, that is what we can very easily understand, that compilation is one time job, but execution is done as many times as we need. But in the case of interpretation, both translation and execution are done always. Every time when you see an execution, or when you are interested in seeing the execution, we must translate it and we must see the execution of that. So, always your interpretation takes more time than the compilation. So, if you are interested in making the things much faster, then we should not go for interpreters, because they will take more amount of time. That is the second point. The third one is, the compilers actually they are very complex, and hence it is not recommended for programs which are in development stage, but interpretation, the design of the interpreter is easier. So, they are suggested for program development stage. So, what do we understand that from this is, see, when you are that is designing, or if you are having a language for which only a compiler is available. So, what we can do is, you compile it, it is a complex process, and it will produce some list of errors, you translate it, and then you can go for seeing the execution of the code. But whereas when you are finding the interpreter, the program, suppose if you are in the development stage, but not in the compilation, that is your final stage, you are keep on trying your program for errors, you are keep on building your program, you are keep on changing your program. So, if it is the case, then we need to do the translation more time than the execution. But once the product has been arrived, or products have been obtained after translating it, and we find that everything is perfectly okay, and we have the object version. So, in that case we will think about only execution. But if you are in a developing stage, we will be keep on changing the code, and every change we have made on the code, we must verify that whether it is successfully doing the objective or meeting the objective or not. So, in that scenario, translation becomes a more frequent job than the execution. So, if translation is a very frequent job, then interpretation is always advisable. If translation is a one time job, but execution is a many time job, then compilation is advisable. So, people who are in the development stage, they can very easily think about that interpretation is good, so that we will be able to track the errors much faster, and they can very easily correct the errors also. Moreover, the interpretation takes less time when you are thinking about the compilation is concerned, if you are thinking about only the translation part is concerned. So, if you are in development stage, better you go with the interpretation rather than going with compilation. And the final part is regarding the errors, where a compiler can recover from minor errors, so thus reporting the errors in the whole program immediately, but whereas the interpreter could not proceed even with minor errors, and they are reporting errors one by one for correction. So, this is a very important point as far as the compiler versus the interpreter choice is concerned. So, the meaning is we are writing a program and we have given it for the translation. Suppose the program has 10 errors. So, if we find that all the 10 errors are displayed, and we will be able to see that is how effectively they can be solved or that is cleared, or they can be debugged. But at the same time, if you are knowing if there are 10 errors, still there are 10 errors, but the translator reports exactly one error at a time, then you think about the situation, 10 times we need to translate to find out all the 10 errors. But whereas when you go for a compiler, it is enough to compile once and you can find out the list of errors available in that. So, if you are able to debug all the 10 errors simultaneously, one time translation is sufficient. But whereas in the case of interpreter, to correct 10 errors, we need to go for 10 times the translation, because every time the interpreter will report one error, it is because of the interpreter is not capable of recovering from the error. But whereas in the case of compilers, they can recover from the error by repairing the errors. So, once it finds an error, it will do some kind of recovery strategies by repairing the errors. See, for example, if I am having an expression called a plus b, and if I forgot to place plus in between a and b, the compiler is going to recover from that by substituting some binary operation in between a and b. Actually, that may not be the choice of your the programmer, but still the intention is to try to find out as many errors as possible from the program, and they all can be simultaneously reported for the programmer. So, we should always find out that the compiler is advisable in terms of debugging, because it can produce maximum errors possible. Actually, it will try to produce all the errors possible available in your code, but sometimes if it is not able to recover from a situation due to there is huge number of errors, in that case your compiler will stop and say that no more debugging is possible, and you have to correct the errors, then we can go ahead with rest of the debugging. So, in terms of error reporting, your compilers are better than the interpreters. So, that is about the your compiler versus interpreter translation is concerned. So, now we have the need for the translators. So, we have already seen that the translators are that is required for communicating or making a program communicatable or executable for in a machine. So, programs written in high level language programs must be executed into must be translated into machine language programs, because high level language programs are readable for human beings, whereas low level language programs are readable only for the machines. So, always there is a need for translating your high level language program into their machine language program. To summarize, we have started with what is the compiler, definition for a compiler, and what are the various translators available, like the interpreter, compiler, then macroprocessor, and then assembler. So, these are the few translators we have seen, and we can even go for more number of translators also. So, the possible questions we have are something like what is the need for translator, and what is the definition for compiler, what is the definition for interpreter, and what are macroprocessors, their source specification, like what is the source language and what is object language, and then what is going to be the comparison in between your compiler and interpreter. So, these are all the possible questions as far as this particular part is concerned. So, with this I conclude this episode. Thank you all.